Okay. Now from this slide, we say that income and saving are associated. Now, what is the meaning of this association? What is the meaning of this chi-square value 128.683? That I need to explain. Okay. So I have explained what is the significant value, what we have to do with the significant value. That is over. Now I am going to explain. What is that? What you mean by association? What is that chi-square value? All these things. Right. Very good. Now, you know the formula for this chi-square. Chi-square equal to O minus E square divided by E. Now we have O. What is O? Observed frequency. Because it is a frequency based test. How many people are there observed? Then E. E means expected. Expected. Okay. Now, what is this O? Where we are getting O? Now, let me go to the earlier output. I will tell you what is O. Now, for example, this is the output, right? So now we have seen this is the output. Same output is available in the PPT. Now let me go to the PPT and I will tell you what is O. Okay. Now this is the cross tabulation table. Okay. Now this 67 people, right? 67 people are there in the income category of 20,000 to 20,000 and the saving category of 5,000. This is observed, actual frequency in each cell. Actual frequency in each cell, we call it as O. Actual frequency, right? So whenever you put a chi-square test, we will get a cross tabulation table. No, in that cross tabulation table, you will get a frequency. Each frequency, we call it as O, observed. What is expected? Now, I will tell later, I will tell how expected is calculated, all these things. Here the formula is given. So all these formula I will come later. Now, okay, so now expected, I want to get the expected also. Now observed is automatically it is coming, that cross tabulation table it is giving. Now I want to get expected also. How to get expected? Now descriptive statistics, cross tab, in the cross tab. Okay, now each cell we have observed. In each cell I want to have expected. Then we will go to the cell. Each cell I want to have expected. Each cell I have O. Okay, O minus E. Okay, I need to get each cell. Then click each cell. Then observed is already there. Then I have to click this expected. If I click this expected and continue, then I will get this table, right? This table. So 44, like all this table I have put later in later slide also, right? So this expected value table, all these things. Okay, that.
Excuse me, sir.
Yes, yes.
Sir, please can you show it once again?
Which once again? Which one you are asking?
Sir, the expected and the observed table.
I will come. Okay, I will come. I will put, no problem. I will tell again and again, no worry. Eh? Okay. So now, so this is the output of the expected and the actual. So this 67 is the observed. This is the output. See, whatever I click, whatever output I have pasted here. All right. So 67 is the observed. 44 is the expected. Now to find out that chi-square value, Otherwise, we call it as calculated value. I-square value is otherwise that 128.683. No, how we are getting observed minus expected square divided by E. You will get the many rows. If you sum it, then you will get the value. That value is the calculated value. So now 67 is the observed, 44 is the expected, right? So now 42 is the observed, 41.3 is expected. How the expected value is calculated, that I will come later. No worry, no worry. I will explain that. Now what I am telling is, now to find out the calculated value of this calculated value of 128.683, I am using a formula. What formula I am using? This formula, O minus E square divided by E. Alright. So what is O? O is observed. Observed means how to get observed and expected. Observed means, let me go here. Okay, let me go again. Please listen. Please listen. Okay. Analyze descriptive statistics. First, I will put observed alone, then you will get, okay, if you put the cross tabulation, then automatically you need not click anything. You will get this, okay, so that already clicked, that is why both results are coming. Okay. So let me remove this expected. Then, okay, I am not touching anything, just you put one into the row, another into the column, you say okay, then you will get this 67, 42, 13, that is the observed frequency for each cell. Okay, observed means actual number of people in each category, that is the observed. Now, I want to have expected. Okay. Now, if I want to have expected, analyze descriptive statistics. Okay, cross tabulation. Each cell I want. So I am going to the cell. I am clicking this expected and continue and I'm telling okay. Then I'm getting this table. This is the table I have shown there. Okay, 67, 44, 42, 41.3. All right. Now, is it okay? How to get expected? What is the meaning? I will come later. What is the meaning? I will come later. Now, I have O and I have E. Okay. Now, what you can do? Okay, by using this O minus E square divided by, you will get many columns. Okay, first O column, E column, then O minus E square column, then O minus E square column divided by E column. Submit all these things. Finally, you will get value. That value is 128. Very good. Okay, now. Sir, what is this, sir? Okay, but please understand, these are all not required. But even then, we need to understand the kick behind this test. Okay. Now, let me quote a small example. Okay. What is this example? Let us assume that there is a MPhil class. In that MPhil class, there are only 8 students. Small classroom. Okay. Only 4 tests are there. Okay. In each test, 2 people can sit. So 4 tests, 8 people. Among the 8, there are 4 boys, there are 4 girls. Right. The college is free. MPhil student, apart from that, free college like Pondicherry University. Which means anybody can sit with anybody, no problem. Any boy can sit with any girl, no problem. Right. Now, we have 4 boys, 4 girls. Let us take the boy 1. right? 4 girls. He has come to the college for 100 days. He has come to the college for 100 days, university for 100 days, right? Then what is expected? What is normal? If it is a normal behavior, okay, 25 times he can sit with this girl, 25 times he can sit with this girl, 25 times he can sit with this. This is the expected. 100 divided by 4 expected. Each girl he can sit, which means no problem. Okay, which means what you mean by no problem? He is treating Kavita also same, Kuili also same. Whether it's Kuili or Kaili or Madhumida, no problem. Wherever there is a place, he is sitting. Okay, so expected is 25. He is going along with that, which means no problem. But contrary to the expectation, what is he doing? The boy one sitting 70 times with this girl, Kavita. This Kaliyappan B1 is sitting with Kavita 70 times. With Kuili only 5 times. Only no other girl he is sitting. But why he is sitting 70 times? Purposefully, he wants to sit there. Why? Because he is having something in his mind. He wants to sit with that girl. Even some boy or instead of Kaliyappan, some for example, Lenin is sitting. He will ask Lenin, hey, go. He will remove Lenin and he will sit there. Okay, so which means boy one associated with girl one. So here what is 70? It is a frequency, 70 times. 70 times. Okay, so 70 times, that is his actual observation. 70 times he is sitting with that girl. Okay, so what is expected? You should have sat with that girl only 25. O is 70. Expected is 74, 25. O minus E. Okay, so 70 minus 25, right? What will happen? Around 45, right? So 45 square, I will get some high square value. All right. If observed also 25, okay, all 20, expected also all 25, expected actual also all 25. Then O 25, E 25, my high square value will be 0, no high square value. Okay, so high square value will be very, very less. Okay, so O is more and more. Okay, so for example, if O is 80, then my high square value will jump. Okay, when high square value jump, which means the association, level of association will jump. Okay, now when it is 70, we say boy 1 is associated with girl 1. This is called the association. Now, like the same, category 1 associated with category 1. Saving category income associated with saving. That is what we are going to test with the I-square test. Right? So now we will get this calculated value. We will get the calculated value. Okay, so observed minus expected, we will get more and more. Now, okay, now we will see here. Okay, now normally what we will do is, we know that, okay, by use our test, our calculated value is 128. Okay, from this value I am telling, calculated value is 128. Okay, my calculated value is how much? 128. How it is calculated? By using O minus E. Very good. E is greater than table value. Okay, what is table value? What is table value? Now, this is the I-square test table. Now, I know that from the result, I got the degrees of freedom of 16, right? What is the degrees of freedom? 16, right? Now let us see. Now let us see how to see the table value. Okay, all these things not necessary, but okay. Now people are doing. You need to understand what people are doing. So calculated value is 128. Table value how to see. Now 16 degrees of freedom. Now let us see at a 5% level of significance. 26, alright, 0.296. Significant level 0.05. What is this 0.05? I will come later. 5%. Okay. 5% error we are accepting. That is what above that we don't accept. Okay. So now 16, 26.296. This is nothing but the table value. Now, calculated value is 128.683. Table value is 26.296. Okay, the calculated value is greater than the table value 26 at the degrees of freedom 16 in the 5% level of significance in the I-squared table. So this is what we have seen. The calculated value is greater than the table value. So we can reject the null hypothesis and we accept the alternate hypothesis. Right. Right. So this is the how some people use table values and they will use calculated value, all these things, but we don't require all these things. Yeah, table value, why unnecessarily looking at the table? Because here itself we are getting the result. Here also we are rejecting the null hypothesis. If by looking at the mere significant value, it is less than 0.05, we are rejecting the null hypothesis. Okay, so both the results are same. So we need not see table value all this. Okay. But one thing let me tell you, why I am showing the table value. Now see the table value. See the table value. Now these are all the calculated values. These are all the calculated values. Now at 16, level of significance is 0.995, 5, 6, 20, 23, 26, 28, 29, 32, 34. And that it is going on increasing. Now look at the significant value. Now when the significant value is decreasing, can you see the decreasing? Can you see the decreasing? Okay. Now when the highest calculated value increases, then significant value will decrease. All right. So calculated value increases. Significant value will become less than 0.0, less than it will go. It will decrease. So when the calculated value increase, it will be significant value will decrease. Right. So when my calculated value increase, when observe instead of 70, I'll get 80. 90. Oh, more and more association, not ordinary association, very thick association. Alright. So calculated value will increase when O is deviating from the E. When O is deviating from E, O is deviating from E, which means I-square value will increase, which means there is an association. There is an association. Right, very good. So now, now let me test somebody. I say that null hypothesis is there is no significant association between two variables. Right? No association. When there is no association, I have told you. Okay. Now listen. Oh, right. Now, okay. Now look at the table. Look at the table. These are all I-square calculated value. Right. Now look at our degrees of freedom 16. 5. Simultaneously look at the 9. Okay. 0.975, 0.2, 0.1, 0.05, 0.025, 0.02, 0.01. It is decreasing. Okay. Now look at the calculated value. 5, 6, 20, 23, 26, 28. It is increasing. So when my calculated value increases, my significant value will decrease. This one probably you should have understood. Right. Now let me go to the formula. When my calculated value, okay, chi-square value increases, right, beyond 26, then, okay, if it is 30, okay, then my significant value will be less than 0.05. If it is less than 0.05, I will say null hypothesis rejected. Okay, we will say no association. No, there is an association. Null hypothesis rejected, which means there is an association. When I will get more than 26, when I will get more than 30, when O is greater than E. When both are equal, when O equal to E, my calculated value will be 0. I will not get 26. I will not get 28. Right? I need to, if there is an association, I should get to more than 26 at 5% level, because table value is 26 at a 5% level. When I will get more than 26, then my observed is more than this expected, right? So my chi-square value increase. So which means there is an association. We will reject the null hypothesis, there is an association, right? Okay, now when we will accept, when the null hypothesis, when we will say there is no association, when E or O equal to E. When O equal to E, 25 minus 25, 0. My calculator value also will be 0, which means no association. We cannot say he is sitting with the 25 times with that card. 25, we expected also 25, no problem. Okay, no association. No association. Right, very good. So now what you need to know is, okay, this one. This you know, already I have taken. Okay, so what we have to do? Okay. Okay, so now we know what is associated, right? Some frequency is more than expected. Okay, observed is more, that is what. Okay. Now, from this table, it is clear that significant value is less than 0.05, which means we have to reject the null hypothesis. Null hypothesis, no association. No association is rejected, which means there is an association. Right. Now, from this table, from this chi-square test, we say that there is an association between income and saving. That is what we are telling. Now, whenever we say there is an association, then we should not stop. For example, somebody, okay, for example, yeah, Madan sir is telling me, sir, that class is mosam, sir. That class is bad, sir. Why, sir? Why you are telling, sir? That class, bad class, sir. Why bad class, sir? Because there, boys and girls are associated, sir. Okay, income and savings are associated. Like that, he is telling, boys and girls are associated. Then I will ask Madan sir, sir, you are telling they are associated. Then immediately I will ask, which boy is associated with which girl, sir? Yes or no? Whenever we say income and saving associated, we need to know which income category and which is saving category are associated. Right? That is called the post hoc test in I-square. Okay. Okay. So first we will check the significant value. We will say they are associated. Over. We need not understand anything. Now, after having stated they are associated, we should not stop. We should go further deep to tell which income category is associated with which saving category. That is called the post hoc test in I-square. In the post hoc, we have three options. Three possible. We have many options. Okay, we have many, right? Okay. Now we'll use a very simple one. Okay, but it is little difficult to understand. Please come with me. Okay. Now I'm using very simple post hoc column percentage. I'm using post column percentage. I'm going to use. Now how I am going to use column percentage? Now, okay. Now I'm doing here. Analyze. Descriptive statistics, crosstab, cells. Here I have each cell. I want to have column percentage. In each cell, I want to have column percentage. Okay. Now let me click the column percentage. I do not want to have the expected. Okay, very good. Column percentage. Okay, then I am getting this output. So 37.2, 22.8, 45.4, like that I am getting a column percentage. So this column percentage I am having here. Okay, now how to find out? Okay. Now let us look at the last column, total. That is the what is the last column? Up to 20,000 saving income category, right? Totally 124 people are there out of 552 people. Total 552. Out of these 552 people, this income category people are 124. 124 out of 552, which means 22.5%. So in the overall total, this income category people are 22%. Now let us look at this saving category alone. 5,000 saving category alone, 196 people. Out of this 196 people, here 67 people are there, which is nothing but 34.2%. In the overall total, their income category people are only 22% of people overall. But in this saving category, 34% of people are there, which means more than 22, which means more number of this income category people, more number of this income category people are available in this saving category of 5,000, which means this up to 20,000 income category people associated with this up to 5,000 category people. Okay, that is associated. Fine. Now let us come to the last one. Let us come to the last one. Okay. Now, okay. So out of this, more than 50,000 and above category. Out of this total, okay, there are around 52 people. That is 9.4% of people. But out in this saving category, out of 21 people, out of 21 people, 10 people are there. Okay, which means 47 people of this income category are in this saving category, which means 50% of the people are in the same category. So we can say above 50,000 income category people are associated with this more than 20,000 saving category, right? So now we can say, we can use, see now very simple form, okay. So we have to look at this percentage, we have to look at this last total column percentage, total column percentage. If any of this percentage are more than this one, any of the, look at the any of the column percentage. So this, with respect to this one is more. This is also right. So with respect to this one, this is more. But this saving category we have associated with this income category. So we have to remove this one. Next one is this one. Then we have to say above 5,000, above 20,000, above 5,000 are associated. Like that we can see by using column percentage. By using column percentage.